Okay, let's discuss the next question. Let Q denotes a queue which is containing 60 numbers and S be an empty stack. Okay, head Q returns the element at the head of the queue without removing it from the queue. Similarly, top S returns the element at the top of the S without removing it from the stack. So consider the following algorithm which is given. Okay, now see this. The algorithm is, while Q is not empty, then you will execute further, and if S is not, or if S is empty or top of S is less than head of Q, then you will execute this. It means you will delete the element from the queue and you will push to the stack. These two steps. Otherwise, it means if there is at least one element in the stack, or the element at the top of the stack is having value less than equals to the element at the head of the queue, then else block, then this block will execute. Otherwise, you will pop that element from the stack and you will insert the element back to the queue. So they are asking, if such a queue contains 60 numbers or 16 elements, then maximum possible number of times the while loop in the algorithm will execute. Okay. So let me take some examples. Let me take some simple example. Okay. So suppose if the queue contains just two numbers. Suppose if the queue contains just two numbers, 2 and 1, and this is the stack. Okay. Now let's start the algorithm. So initially here I am writing the count, that how many times our while loop is executing. So initially the count becomes 1, the control comes in the loop. While Q is not equal to empty, the condition true, this is my Q. If S is empty, yes, this is my stack, initially a stack is empty. So what you will do, you will delete the element, this is front and this is rear. You will delete the element and you will push to the stack. Okay. After that, once these two steps are over, again the control goes back, and while Q is not equal to empty, again condition is checked, and again the Q is not empty, the condition is true, so count becomes 2. After that, now you will check, if S is empty, no, stack is not empty. If this is false, then you will check top of S less than equal to head of Q. The top of S is 2 and head of the Q is 1, so 2 less than equals to 1. So as of now this is not available. So 2 less than equals to 1, the condition is false. So if this condition is false, then else block will execute. In the else block, what it says, you pop this element from here and you push back and you insert back it to the queue. You can assume the queue bit like the queue which is like a linked list. Okay, you can assume it like a queue. I mean, there is no such constraint regarding the space. From the question that we are getting, that there is no such constraint regarding that how you will implement it. But the thing is that how many times this function will execute, this while loop will execute. Okay, so you can assume that the queue is like a circular in the implementation. Okay, so now this is the rear and this is the front. So you inserted. After that, again you will go back and you will check while Q is not equal to empty, and again the condition is true. So count becomes 3. When count becomes 3, then you will go inside. If S is empty and now stack is empty. So if stack is empty, then what you will do? You will delete the element from the queue and you will push to the stack. Now this element is not available in the queue. Only 2 is available in the queue. After that, now you will check. So if S is empty, then you will do insertion, and then after this is over, again the control goes back to the while loop and count increase by 1 unit more. Okay. Now if S is empty, so if S is empty, the condition is false. Then you will execute the second condition. If top of S is less than equal to head of Q, top of S is less than equal to head of Q means 1 less than equals to 2. Yes, condition is true. Then what you will do? You will delete the same element and you will push to the stack. So this time the queue becomes empty. So this time the queue becomes empty, and when the control again goes back, while Q is not equal to empty, the condition is false and you will stop. So you see that if there are 2 elements, then how many times this while loop execute? 4 times. 1, 2, 3, 4. Okay. Let's take another example in which, suppose if there are 3 elements, okay, then how many times it will execute? And then we can make some analogy that for n elements, how many times it can execute. So suppose if there are 3 elements, and the elements in the queue are available in this order 3, 2, 1. Okay, and this is the stack, and this is here I am maintaining the count. So initially this is my rear, this is my front. So start the algorithm. While queue is not equal to empty, yes, so count becomes 1. Initially stack is empty, yes, so what you will do, you delete the element and you push to the stack. Once this step is over, now this is the front and this is the rear. After that, again you will go back and you will check, while queue is not equal to empty, the condition is true, so count becomes 2. And now you will check, if stack is empty, no, stack is not empty. So if this condition is false, then you will check if top of S is less than equals to head of Q. The head of Q is 2. 3 less than equal to 2, but this condition is false. If this condition is false, then else block will execute. The else block says that delete this element from here and insert to the queue back. So now what will happen? This element is no more available here, and this is the new rear. After this, again you will go back, you will check while Q is not equal to empty and the condition is true, so count becomes 3. After this is over, now you will check if stack is empty, yes, stack is empty. So what you will do, you delete the element and you push to the stack. So now the new front of the queue is this. And once this is over, then again you will go back and you will check while Q is not equal to empty and the condition is true, so count becomes 4. And this time stack is not empty. So what you will do now, you will check if top of the stack is less than equals to head of the queue, and the condition is again here actually false because the top of the stack is 2 and head of the queue is 1. So 2 less than equals to 1, condition false. If this condition is false, go to the else block and pop this element from here and push back to the stack. So now this 2 is no more available in the stack. If this is not available, so what will happen? Again you will go back and you will check while Q is not equal to empty. So the condition is again true and the count becomes 5. After this, now you will check if stack is empty, yes, so you will delete the element and you will push to the stack. So now this element is not available here. Okay, so this is the new front and this is the new rear. After this is over, then what you will do, you deleted the element and you inserted into the stack, and again you will go back, you will check while loop, while Q is not equal to empty and the condition is again true, the count becomes 6. After this, now this time stack is non-empty, so you will check if top of the stack less than equals to head of the queue, 1 less than equals to 3, condition is true. If this condition is true, then what will happen, you delete this element and you push to the stack. So now this element is not available, so front and rear both are same. Again you will go back, you will check while Q is not equal to empty and the condition is true, so it becomes 7, count becomes 7. And this time the stack is non-empty. Okay, but after this you have to check the statement. If top of the stack is less than equals to head of the queue, so what is the top of the stack? Top of the stack is 3, 3 less than equals to 2 and the condition is false. If this condition is false, then what you will do, you delete this element from here and you push back to the you insert back to the queue. So you insert back to the queue. Once this is over, again you will go and you will check while Q is not equal to empty, condition is true and the count becomes 8. And after this is over, because stack is non-empty, then you will check top of the stack is less than equals to head of the queue. Head of the queue is 2 and the condition is true. Then what you will do, you delete this element and you push here. And again you go back and you will check while Q is not equal to empty and the condition is true and count becomes 9. And again you will check, this time stack is non-empty, so you will check top of the stack less than equals to head of the queue, and this time the top of the stack is 2, 2 less than equals to 3, the condition is true. If the condition is true, you pop this, delete this element and insert into the queue. And after that again you will go back and this time your queue is empty. When your queue is empty, you will stop. So when there are 3 elements, how many times the while loop execute? 9 times. So when the number of elements were 2, it execute 4 times. When it is 3, it executes 9 times. So it is like this. 4 is nothing but 2 square, 9 is nothing but 3 square. So when the number of elements are 16, it will execute around 16 square time, which is nothing but 256. So the maximum number of times the while loop execute is 256. So here the answer is 256.